Have you ever wondered what it feels like to fly inside a machine that can take off without a runway, hover perfectly still in the sky, land almost anywhere, and yet travel at speeds once thought impossible for helicopters? What if I told you that one aircraft is quietly changing the future of aviation with technology that looks decades ahead of its time? At first glance, it appears to be just another helicopter. But hidden beneath its sleek body is a collection of engineering innovations that are redefining safety, speed, comfort, and efficiency. Today, we're taking a deep dive into one of Airbus' most advanced helicopters, exploring every detail from its incredible design to the powerful technology that makes it one of the most impressive rotorcraft ever built. By the end of this video, you'll understand why experts believe this aircraft represents the future of helicopter aviation. Modern aviation has always been driven by one goal: moving people faster, safer, and more efficiently. Fixed-wing airplanes transformed long-distance travel, while helicopters opened entirely new possibilities by allowing aircraft to reach places where traditional airplanes simply couldn't operate. Whether it's rescuing injured climbers from remote mountains, transporting VIPs between busy cities, supporting offshore oil platforms hundreds of kilometers from land, or carrying out military and law enforcement missions, helicopters have become an essential part of our daily lives. Among the world's leading helicopter manufacturers, Airbus has built a reputation for innovation that spans decades. Every new generation of aircraft introduced by the company has brought significant improvements in safety, performance, fuel efficiency, and passenger comfort. Instead of simply making helicopters bigger or more powerful, Airbus has consistently focused on making them smarter. The aircraft you're looking at is an excellent example of that philosophy. From its smooth aerodynamic nose to its carefully sculpted fuselage, every curve serves a purpose. Nothing on this helicopter exists only for appearance. Every surface has been designed to reduce drag, improve airflow, and maximize performance during flight. One of the first things you'll notice is its striking paint scheme. The combination of bright white and deep navy blue creates a modern, futuristic appearance while highlighting the helicopter's sleek lines. Thin orange accents add contrast without overwhelming the overall design. Under sunlight, the polished surfaces reflect the environment beautifully, giving the aircraft an elegant yet powerful presence. But beauty is only the beginning. The real magic begins above the fuselage. The main rotor system is the heart of every helicopter. Unlike an airplane, which relies on fixed wings to generate lift, a helicopter creates lift through rapidly spinning rotor blades. Every rotation generates enormous aerodynamic forces capable of lifting several tons into the air. Designing these blades is one of the greatest engineering challenges in aviation. Engineers must create blades that are incredibly strong yet lightweight enough to spin thousands of times every minute. They must withstand changing temperatures, heavy rain, dust, strong winds, and enormous centrifugal forces while maintaining perfect balance. Airbus has invested years of research into improving rotor blade technology. Modern composite materials have replaced much of the older metal construction, making today's blades lighter, stronger, and more resistant to fatigue. Composite materials also absorb vibration more effectively, resulting in smoother flights for both pilots and passengers. Vibration has always been one of the biggest challenges for helicopter manufacturers. Early helicopters often produced intense shaking throughout the cabin, making long flights uncomfortable and increasing maintenance costs over time. To solve this problem, Airbus developed sophisticated vibration reduction systems that continuously minimize unwanted movement during flight. These systems may not be visible from the outside, but passengers notice the difference immediately. The ride feels smoother, quieter, and far more refined than helicopters built just a generation ago. Another remarkable innovation lies inside the transmission system. The engine itself spins at extremely high rotational speeds, but those speeds cannot be transferred directly to the rotor blades. A highly engineered gearbox converts engine power into the precise rotational speed required for safe flight. Every gear inside this transmission is manufactured with extraordinary precision, often measured within tiny fractions of a millimeter. The gearbox constantly handles tremendous loads while maintaining perfect synchronization between the engines and the rotor system. Engineers design it to operate reliably for thousands of flight hours under extreme environmental conditions. Powering this helicopter are advanced turbine engines capable of producing enormous horsepower while remaining surprisingly compact. Unlike automobile engines, helicopter turbine engines operate by compressing incoming air, mixing it with fuel, igniting the mixture, and using expanding gases to drive multiple turbine stages. This process delivers an exceptional power-to-weight ratio, allowing relatively small engines to lift heavy aircraft with impressive efficiency. Modern digital engine control systems constantly monitor temperatures, fuel flow, air pressure, rotor demand, and dozens of other parameters every second. Instead of relying solely on pilot inputs, onboard computers automatically optimize engine performance throughout every phase of flight. This automation improves efficiency while reducing pilot workload, especially during demanding missions. Imagine approaching a confined landing zone surrounded by trees, power lines, or buildings. The pilot must monitor altitude, speed, wind direction, engine performance, surrounding obstacles, navigation systems, and communication with air traffic control simultaneously. Advanced flight computers assist by continuously analyzing aircraft performance and providing critical information instantly, allowing pilots to focus more attention on flying safely. The cockpit itself represents another major leap forward. Gone are the days of crowded instrument panels filled with hundreds of analog gauges. Instead, large digital displays provide pilots with customizable flight information in a clean, organized format. Navigation maps, engine status, weather data, terrain awareness, moving maps, system diagnostics, and communication information can all be displayed simultaneously. This glass cockpit dramatically improves situational awareness. Rather than searching across dozens of individual instruments, pilots receive integrated information presented exactly when and where they need it. Many Airbus helicopters also include advanced autopilot systems capable of maintaining altitude, heading, airspeed, and even stable hovering under certain conditions. Hovering might appear simple from the ground. In reality, it is one of the most demanding maneuvers in aviation. Unlike an airplane, which naturally moves forward through the air, a hovering helicopter must constantly balance dozens of changing aerodynamic forces. Even small wind gusts require immediate corrections. Modern flight control computers assist the pilot by making hundreds of tiny adjustments every second, helping maintain remarkable stability. This technology proves especially valuable during search and rescue operations, offshore platform landings, medical evacuations, and mountain rescue missions where precision can literally mean the difference between life and death. And while the pilot remains focused inside the cockpit, another remarkable engineering achievement is quietly working behind the scenes, the sophisticated rotor system that not only keeps the aircraft stable but also dramatically reduces noise, making this helicopter far quieter than many people expect. The reduced noise signature is more than just a comfort feature. In today's aviation industry, airports and city authorities are becoming increasingly strict about environmental impact. Helicopters that generate excessive noise often face operational restrictions, especially in urban areas. Airbus engineers address this challenge by redesigning the rotor blade tips, optimizing airflow around the fuselage, and improving the tail rotor system. The result is an aircraft that produces significantly less noise while maintaining exceptional performance. This allows operators to fly into locations where older helicopters might face limitations, opening new opportunities for emergency medical services, executive transportation, and urban air mobility. Passenger comfort has also become a major priority in modern helicopter design. Stepping inside the cabin immediately reveals the difference. Wide doors make boarding easy, while the spacious interior offers generous headroom and legroom. Large panoramic windows allow passengers to enjoy breathtaking views during flight, whether crossing mountain ranges, flying above coastlines, or approaching a busy city skyline. Natural light fills the cabin, creating an open and welcoming atmosphere. The seating configuration can be customized depending on the mission. Corporate operators often choose luxurious leather seats, premium lighting, sound insulation, and executive interiors that rival private business jets. Medical evacuation operators install advanced life support equipment, stretchers, oxygen systems, and specialized medical workstations. Search and rescue teams configure the cabin with rescue gear, emergency supplies, and rescue hoists. Offshore transport companies prioritize durable seating and maximum passenger capacity, while law enforcement agencies equip the aircraft with surveillance systems and communication equipment. This incredible flexibility is one of the reasons Airbus helicopters are trusted across so many industries. A single platform can perform completely different missions simply by changing the interior equipment and onboard systems. Safety remains the foundation of every Airbus helicopter. Every major component is designed with redundancy in mind. If one system experiences a problem, backup systems are ready to take over, allowing the aircraft to continue flying safely. Critical flight computers constantly monitor engine performance, hydraulic pressure, electrical systems, fuel flow, gearbox temperatures, and rotor health. Thousands of pieces of information are analyzed every second, alerting pilots long before a minor issue becomes a serious problem. Modern helicopters are also equipped with advanced terrain awareness and warning systems. These systems compare the aircraft's flight path with digital terrain databases, warning pilots if they are approaching mountains, towers, or other obstacles. Weather radar helps crews avoid dangerous storms, while satellite navigation provides highly accurate positioning almost anywhere in the world. One of the helicopter's greatest strengths is its ability to perform under challenging weather conditions. Rain, high temperatures, freezing climates, desert environments, and offshore winds all present unique challenges. Airbus engineers test their helicopters extensively in some of the harshest environments on Earth, ensuring reliable performance whether operating in the icy Arctic, humid tropical forests, or scorching deserts. Maintenance has also evolved dramatically. In the past, technicians relied heavily on scheduled inspections to identify wear and damage. Today, onboard health monitoring systems continuously record data during every flight. After landing, technicians can review this information to identify components that may require attention before they develop into larger problems. Predictive maintenance reduces unexpected downtime, improves safety, and lowers operating costs for fleet owners. Fuel efficiency has become another key focus in recent years. Rising fuel prices and growing environmental concerns have encouraged manufacturers to develop more efficient engines and lighter aircraft structures. Composite materials reduce overall weight while maintaining exceptional strength. Improved aerodynamics reduce drag, allowing the helicopter to travel farther using less fuel. Advanced engine management systems ensure every drop of fuel is used as efficiently as possible without sacrificing performance. Speed is another area where modern Airbus helicopters continue to impress. Although helicopters are generally slower than airplanes, advances in rotor technology, engine power, and aerodynamic refinement have significantly increased cruise speeds compared to earlier generations. Faster travel means emergency patients reach hospitals sooner, offshore workers spend less time commuting, and rescue teams arrive more quickly when every second counts. For pilots, flying such an advanced machine requires extensive training. Before operating the real aircraft, pilots spend many hours inside sophisticated flight simulators that accurately reproduce the helicopter's behavior in every imaginable situation. Engine failures, severe weather, hydraulic malfunctions, electrical faults, and emergency landings can all be practiced safely without ever leaving the ground. This preparation builds confidence and ensures crews are ready to respond effectively under pressure. Every successful flight represents the combined efforts of thousands of engineers, designers, technicians, software developers, mechanics, inspectors, and pilots working together toward one goal, creating one of the safest and most capable helicopters in the world. Looking at the aircraft from the outside, it's easy to admire its elegant appearance. But once you understand the incredible engineering hidden beneath its sleek exterior, your appreciation grows even deeper. Every panel, every blade, every sensor, and every computer plays a role in keeping the helicopter stable, efficient, and reliable throughout each mission. As aviation continues to evolve, Airbus is already exploring the next generation of rotorcraft. Hybrid propulsion systems, sustainable aviation fuels, advanced automation, artificial intelligence, and even fully electric vertical flight are shaping the future. The technologies found in today's helicopters are laying the foundation for tomorrow's aircraft, bringing us closer to quieter, cleaner, and even safer air transportation. The helicopter you've seen throughout this documentary isn't simply a means of transportation. It represents decades of innovation, countless hours of research, and the relentless pursuit of excellence. From life-saving rescue missions to executive travel, disaster response, offshore operations, and humanitarian aid, it continues to prove that modern helicopter technology can accomplish extraordinary things. The next time you see an Airbus helicopter lifting gracefully into the sky, you'll know that beneath its spinning rotor blades lies one of the most sophisticated flying machines ever created, an aircraft designed not only to fly, but to inspire confidence, push engineering boundaries, and shape the future of aviation for generations to come. Thank you for watching, and we'll see you in the next adventure through the incredible world of aviation.